So now we'll discuss trigonometry ratios of certain angles. So let's start with angle 45 degree. So consider triangle ABC. As you can see, it is a right angle triangle with a right angle at B. And if I give you one angle over here is 45 degree. Let's say angle A is 45 degree. Then automatically it means that angle C will also be 45 degree. How? We know that sum of angles of a triangle is equal to 180 degree. Irrespective of the type of triangle, the sum of angles is always 180 degree. So what are the three angles over here? Angle A plus angle B plus angle C equal to 180 degree. Now I am saying that let's say angle A is 45 degree and angle B is a right angle. So this is 90 degree. Plus let's see what angle C will be. So this will be 135 degree. If I take it on the RHS, it becomes 180 degree minus 135 degree, which is 45 degree. So always in a right angle triangle, if one angle is 45, then the other angle is also 45 degree. So let me take this BC and AB. Okay. Now if angle A and angle C are equal, then sides opposite to equal angles, they are also equal. Now what is the side opposite to angle A? BC. What is the side opposite to angle C? AB. So it means BC and AB are equal. So let's say they are equal to A units. Okay. So I'm saying your AB is also A and your BC is also A. Then you make use of Pythagoras theorem because this is a right angle triangle. And then you can say what is the hypotenuse over here? AC. So AC square is equal to AB square plus BC square. That is A square plus A square is equal to 2A square. If you take square root on both sides, you get A root 2 units. Alright. So far we've just seen that if one angle is 45 degree in a right angle triangle, then the other angle is also 45 degree. Sides opposite to equal angles are also equal. Let's say these two sides are A and then the hypotenuse comes out to be A root 2 from Pythagoras theorem. So if that is the case, this is A and this is root 2A or A root 2, then you can easily find the 6 trigonometry ratios. Okay, because to get these trigonometry ratios, you need to know the 3 sides of a triangle, which fortunately you do. So now let me find it for 45 degree. Which 45 degree I can consider? I can take it as this for A also, or I can take it for C also. Let me take sine A, where A is 45 degree. So sine 45 degree, this 45 degree will be the side opposite to this, which is BC, upon hypotenuse, which is AC. Again, Sophie will help you. Okay. Sophie has those cats and her tall orange aunt, so that will help you. So BC upon AC, so it will be A upon A root 2, which is 1 by root 2. You can check your answer from here. Then quickly find out cos 45 degree. That will be what? The side adjacent to this, which is AB, upon the hypotenuse, which is AC. So that will be A upon A root 2, which will be again 1 by root 2. Alright. Then tan 45 degree, you can simply do sine upon cos, or you can make use of opposite upon adjacent formula also. So here you will get it as 1. Now if sine 45 degree is 1 by root 2, what will be cosec 45 degree? It will be 1 upon sine 45 degree. So 1 upon root 2 is nothing but root 2. Similarly, what is sec 45 degree? It is reciprocal of cos 45 degree, which is 1 upon root 2, which is again root 2. Cot 45 degree will be 1 upon tan 45 degree, 1 upon 1, which is equal to 1. So this is a summary of all these angles. So you can easily get these trigonometry ratios if you know the procedure, okay, how to go about it. But still, I would suggest you that you learn them, okay, and in fact, I'll tell you how to learn them also. So no worries if you're not able to do it at the present moment. Now for this triangle ABC, okay, let me take this triangle ABC to be equilateral. Equilateral means all the 3 sides are equal, which means AB, BC, AC are equal. If all the 3 sides are equal, then the 3 angles would also be equal. What are the 3 angles in triangle ABC? Angle A, angle B, angle C. So let me say one angle of this equilateral triangle is X. So if I take angle A as X, angle B is also X, angle C is also X, and what will their sum be? 180 degrees. So this gives me 3x as 180 degree, which gives me my x as 60 degree. Now this is nothing but the value of angles A, B and C individually. So they are individually equal to 60 degree. Now let's say AB, BC, AC, I told you they are equal. So let me say that they are equal to 2A. Okay, so I told you that I am having an equilateral triangle ABC. That means three sides are equal and all of them are equal to 2A units, and the three angles are equal, and let's say they are equal to 60 degree. In fact, there's nothing to say, they are equal to 60 degree only. Then you drop a perpendicular from this vertex A on this side BC, so you get AD perpendicular to BC. Alright. Now you consider this triangle ABD and triangle ACD. Triangle ABD and triangle ACD. Okay. Now here you know that this angle B is 60 degree, and here you see angle C is also 60 degree, equilateral triangle. That means angle B and angle C are equal. If you see this angle ADB, it is same as angle ADC. Both of them would be equal to 90 degree, okay, because AD is perpendicular to BC. So if this is 90 degree by linear pair, the sum would be 180 degrees, so this will also be 90. So 90, 90, so they are also equal. So by AA axiom, and automatically, okay, if you're dropping this perpendicular, it means that this angle A is getting bisected. So this is also 30 degree, this is also 30 degree. So you can also see that angle BAD and angle DAC, they are also equal angles. So by AA or AAA axiom, you can see that triangle ABD and triangle ACD, they are congruent. Okay. Now if they are congruent, we can make use of CPCT, which is corresponding parts of congruent triangles. They are also equal. So I can say that corresponding sides BD and DC, these two sides, they are equal. So if this entire BC side is 2A, right, then if BD and DC are equal, in a way D is the midpoint of BC, then let's say this is equal to A, this is equal to A, right? And also angle BAD and CAD will be equal. Again by CPCT you can say that. So if this is 60 degree, this is 90 degree, this is a triangle. So triangle ABD, here we know 60 degree and 90 degree are the two angles. Say I want to find out angle BAD. So the sum of angles of triangle is 180 degrees. So from here you will get angle BAD as 30 degree. In a similar manner you can go for triangle ADC as well then. Okay. So far this is the information that we have. So here you are having triangle ABC. You are having triangle ABD, which is right angled at D. And here angle A is 30 degree, angle B is 60 degree. Okay, I'm just considering a fragment of triangle ABC. Okay, we divided it in two triangles, right, by dropping AD perpendicular to BC. So I'm considering this part of this triangle, triangle ABD. So this is 60 degree, this is 30 degree, this is 90 degree. We just saw how we are getting these angles. So we said that this AB, all the sides of the original triangle were 2A, and then BD turned out to be A by CPCT. So you can apply Pythagoras theorem over here because this triangle is having angle D as 90 degree. So come on, make use of Pythagoras theorem and tell me what is your hypotenuse in this triangle ABD. The hypotenuse is opposite to 90 degree, that is AB. So AB square is equal to AD square plus BD square. Do I know what is AB? I do, that is 2A. So 2A whole square is equal to AD. I don't know what is AD. AD square plus BD square will be A square. What is 2A whole square? 4A square is equal to AD square plus A square. If I take the A square on the LHS, it becomes minus. So 4A square minus A square is 3A square is equal to AD square. If I take square root on both sides, I get AD as A root 3 units. That is what we have written over here. So basically this is 2A, this is A, and this is what? A root 3. If I have the three sides, what do? I can find out the trigonometry ratios. Okay, now let's see, I want to find it for this angle 30 degree. Okay, so considering this sine A or sine 30 degree, what is the side opposite to angle A? That is BD. What is the hypotenuse in this triangle? That is AB. So quickly substitute, it will be A upon 2A, which is 1 by 2. Alright, then let me find out cos 30 degree. Tell me what is the side, which side is adjacent to this angle A 30 degree? That is AD. And the hypotenuse remains the same, AB. So this is going to be A root 3 upon 2A. AA cancels, you get root 3 by 2. If you have sine and cos, these are your primary ratios. You can find the other ratios as well. So now tan 30 degree is sine 30 degree upon cos 30 degree. Or you can use the formula opposite upon adjacent. So this is going to be 1 by 2 upon root 3 by 2. 2 cancels and we get this as 1 by root 3. Now cosec 30 degree is 1 upon sine 30 degree. That is 1 upon 2, which is 2. cos 30 degrees there with me. I can find out sec 30 degree. It is 1 upon cos 30 degree. So it will be 1 upon root 3 upon 2, that is 2 upon root 3. Then tan 30 is 1 by root 3. Take its reciprocal, that will give you cot 30 degree as root 3. Okay, so again, if you can memorize them, well and good. Otherwise, I'll definitely tell you a trick to do so. So this is how we got the T ratios for 30 degree, this angle. Then in the same triangle, if you remember, this angle was 30 degree. We were focusing on angle A only in this triangle. Now we are considering only acute angles, right? So we can't take angle D obviously. So we are taking now angle ABD right now, 60 degree angle. Okay, so can we have the T ratios for them as well? Yes, we can, provided we know the sides of this triangle, which we already know. So this is AB 2A, this we calculated A root 3, and this we took as A. So what will be sine 60 degree? What is the side opposite to 60 degree? It is AD, and the hypotenuse is AB. So what is AB? It is A root 3, and what is AB? That is 2A. So this becomes root 3 by 2. Then similarly find cos 60 degree, and let's verify what is cos 60 degree turning out to be. What is the side adjacent to this angle? BD upon hypotenuse remains the same, AB. So it's A upon 2A, which is 1 by 2. For tan 60 degree, you can take sine 60 upon cos 60, or you can make use of the other formula as well. So it will be root 3 by 2 upon 1 by 2, 2 cancels, that is root 3. So cosec 60 degree is 1 upon sine 60 degree, that will be 2 by root 3. Sec 60 degree is reciprocal of cos 60 degree, that is 2. Cos 60 degree is reciprocal of tan 60, which is 1 by root 3. So far I was telling you that we are not considering T ratios of 90 degree angle, but now I'll tell you what exactly are the T ratios for this particular angle. But let's see first of all for 0 degree. So again we are considering a right angle triangle ABC, right angled at B. Okay. Now if I want to take angle A as 0 degree, let's understand how we are getting angle A as 0 step by step. So this is my angle A. Now I'm going to reduce the value of this angle. Okay. Let's say initially it was some value. Now I have reduced this. So this is like this. Okay. I have further reduced it. It looks like this. I have further reduced it. This looks like this. So what is happening as I'm reducing the value of angle A? You can see that this length of BC, this side BC. So as angle A is decreasing, the length of BC is also decreasing. Can you see? It's decreasing, decreasing, decreasing. And we see that finally when angle A is decreasing and when angle A becomes equal to 0 degree here, it's just a line, okay, it's 0 degree, there is no angle. You see ultimately BC also decreases to such a value that basically BC becomes 0. So when angle A decreases, the side BC decreases. So when angle A becomes 0, BC also becomes 0. BC becomes 0 means what? B and C coincide. As you can see as well, B and C will then coincide. And then in that case your AC and AB will be the same because B and C are coinciding. So AC becomes equal to AB. Now with that knowledge in mind, we can find out sine 0 degree. So what is sine 0 degree? You see what is opposite to angle A? It is BC, and what is the hypotenuse? AC. But I just told you that BC is 0 when angle A is 0. So BC is 0, 0 upon AC it is 0. So there is a logic behind why trigonometry ratios of 0 degree are coming the way they are. Then considering cos 0 degree. So what is the side adjacent to angle A? That is AB. Hypotenuse AC. Now I just told you AB and AC are equal, okay, when angle A becomes 0. So this means they can get cancelled. So that becomes 1 only. Okay, tan 0 you can find out from sine 0 upon cos 0, which is 0 upon 1. So 0 upon 1 is 0 only. Now if you know these three ratios, you can easily find their reciprocals as well. So cosec 0 is 1 upon sine 0, which is 1 upon 0. Now anything divided by 0 is infinity, which is not defined. Okay. Then you consider sec 60 degree, it is 1 upon cos 0, 1 upon 1, which is 1. So just make this correction over here. This is 0 degree. Okay. So cot 0 is what? 1 upon tan 0. And what is tan 0? It is 0. So 1 upon 0 is infinity. Again, it's not defined. Okay, this is a general rule of thumb that anything divided by 0 is not defined. So these are the 6 trigonometry ratios for 0 degree. So now we find out the trigonometry ratios for 90 degree. So here we increase the value of angle A. And as we increase it, we want it to be 90 degree. Okay, so earlier if angle A looked something like this, now it should look like this or like this. Okay, it should be 90 degree. So you notice that if angle A is increasing, what is happening to the length of the side AB? AB is decreasing. So by this logic, if angle A becomes equal to 90 degree on increasing like this, then your AB should become equal to 0, and that is what is happening also. AB becomes equal to 0. Or in other words, A and B coincide. If that is the case, then distance of this point A from C and B from C should be the same. That means AC should be equal to BC. So AB is 0, AC and BC become equal when angle A is 90 degree. So now I know the values of the three sides. I can find out the trigonometry ratios for 90 degree angle. So sine 90 degree. Okay, that is basically sine of A. What will that be? Opposite side upon the hypotenuse. That is BC upon AC. Now here BC and AC are equal. So I can write it like AC upon AC. They cancel and they give you 1. So sine 90 degree is equal to 1. Then we have cos 90 degree. What is the adjacent side to angle A? AB upon the hypotenuse is AC. So here we see that AB becomes equal to 0. So 0 upon AC it will be 0. Okay. Tan 90 sin 90 upon cos 90, that is 1 upon 0. Anything divided by 0. Is it defined? No, it is not. So not defined. But are we done here? No, our work is not done. We need to find 3 more trigonometry ratios. But they are easy to find. Don't worry. Cosec 90 degree. It's simply the reciprocal of sin 90 degree. So that is 1 upon 1 equal to 1. Sec 90 degree reciprocal of cos 90 degree. That is 1 by 0. Is 1 divided by 0 defined? No, so this is not defined.